Hi, and welcome to Xamarin University. This is XAM110, Introduction to Cross-Platform Mobile Development. And my name's Kim Philpotts. You can see my email address and my Twitter handle right here on the slide. If ever you feel you want to reach out to me, please feel free. Before you continue, you should download the class materials available at university.xamarin.com. The primary focus of our class today is going to be to learn how to maximize our code reuse across our different supported platforms, but without sacrificing the native experience we want to deliver onto each one. To do that, we'll look at two different approaches for sharing code across platforms. First, shared projects, and then portable class libraries. And in both scenarios, we'll also examine how to use platform-specific features. We're going to start this class by quickly looking at the types of things that we can and will want to share. There are several things we want to think about. First, let's set our expectations over how much shareable code you'll actually have. Then, we'll look at common elements we might include, such as data access, and finally very quickly look at a couple of places where we can get reusable components from. The first thing to note is that we'll always have some platform-specific code, shown on the slide here in red. On average, that'll be anywhere between 15 to 30% of your project, and that'll include things like UI definitions, controller code to get your UI controls into our logic, and any services that are coupled to presentation, things like alert views. Of course, different projects and platforms will vary, and keep in mind that some applications will fit nicely into these statistics, and some obviously won't. The shared code will often be split between code that we write, shown here in purple, and the code that we pull in from third-party sources, which is shown in green. Again, these are averages, which may or may not fit completely with your app model. But let's focus first on the reusable components that we might add into our application. These would be blocks of code that can be used across different applications, not just platforms. We might build them ourselves, download them, or even purchase them. The point is that they're not unique to our application's logic. And given that it's a large piece of most applications, let's look at a few very common components you might consider using. Xamarin has several additional cross-platform libraries which are available for you to use that have a unified API for accessing platform-specific features across iOS, Windows Phone, and Android. These are all open source and available through GitHub, which you can use and modify however you like, although most people just use them as is. We have Xamarin.social module, which has Facebook and Twitter support, Xamarin.auth, which is used for OAuth support, and Xamarin.mobile, which is a component that gives you location, camera, and photo access. Another area to look at is the .NET Foundation, which is www.netfoundation.org. There you'll find a ton of open source .NET code that you can use, and you'll also find that many of Xamarin's libraries have been contributed into their effort. Also fairly recently, James Montemagno has helped drive some community plugins for Xamarin, which are nice simple code modules that basically just do one thing, but do them really well. You can find these at github.com/Xamarin/plugins. Another component to consider is Xamarin Forms. This is a simple API that enables developers to quickly and easily build shared user interface code for iOS, Android, and Windows Phone. You build your UI with C# objects either in code or XAML, and Xamarin Forms then creates the application UI using the platform's native controls. So for example, if you add a button to a page in Xamarin Forms, it'll actually create a UI button in iOS, an Android button widget in Android, and a XAML button in Windows Phone. Xamarin Forms is intended primarily for data display applications, and it doesn't encapsulate every UI element on every platform. Nor is it designed to completely replace the ability to natively create a UI when you need complete flexibility. Instead, it supports the most common UI paradigms such as basic controls, navigation, and maps in a cross-platform fashion, which you can then share between your different platforms. This dramatically increases your local shared code because we no longer define the majority of our UI in platform-specific projects. It's also possible to create custom renderers for individual platforms, which allows you to get right down to the OS level controls and implementations. And you'll find that most Xamarin Forms projects of any complexity will probably make good use of these. So if Xamarin Forms sounds interesting to you, have a look at xamarin.com/forms. It provides some really good links and information that'll help you work out which Xamarin approach might work best for you. And you should definitely attend the classes in Xamarin University that focus specifically on this technology as well. One area that you should always try and share is your data access layer. In Android and iOS, this is pretty easy because they actually both include SQLite, and Xamarin includes an ADO.NET provider to read and write the data. Windows Phone has its own database, but you can use SQLite through an open source project available at code.google.com. There's also a very nice ORM called SQLite.net, which is also open source and allows for a nice abstraction over top of your database. It even supports task-based async operations, so your UI doesn't block while the application does queries and updates. And finally, Microsoft announced support for mobile with Entity Framework 7, including Xamarin support. It's still in development, but will hopefully ship soon. You can get more information on local cross-platform data access in the Xamarin University class XAM110, Data in Mobile. You can also choose to push your data into the cloud with a variety of components available on the Xamarin Component Store for working with services such as Azure, Amazon S3, and Dropbox. And even if your cloud provider of choice doesn't have an existing component, most of them will have some kind of web layer to access their services. And speaking of web services, you can often share the access code to hit web services. For RESTful services, Xamarin supports the new HTTP client API that was introduced in .NET 4.5. This is a high-performance async model for interacting with HTTP-oriented services. For platforms where HTTP client is not directly available, such as in .NET 4, you can add a NuGet package to provide the API as a PCL. So this is the preferred way to hit REST services supplied with the framework. The core libraries that ship with Xamarin also support the older HTTP web request and web client APIs if you already have code that relies on these APIs. There are several third-party options here as well. ServerStack, REST-Sharp, and Hammock are all pretty popular options that are available through NuGet and the Xamarin Component Store. When processing the data for XML, you can use the built-in system.xml or link.xml, which is also very nice. For JSON data, you can use the system.json library, or my preference is to use Newtonsoft's JSON.NET library, which is available both in the Component Store and NuGet. For SOAP-based services, you have two primary choices. With the Business Edition of Xamarin, you get access to WCF, specifically the basic HTTP binding variety that supports WSI basic profile-based services. This API is available in most of the portable class library profiles, so you can push your web client code into PCL-based assemblies. There is also support for older client-side ASP.NET ASMX-based web services. These are also usable inside a PCL, as long as you add in the NuGet Microsoft.NET.HTTP package that allows support for the system.web assemblies the client proxy depends on. If you're interested in more information on cross-platform web services, make sure to check out the XAM110 Introduction to Cross-Platform Web Services class. Many of these components are distributed in binary form, and there's support in Visual Studio and Xamarin Studio to locate and download them from two different places. The first, which you probably already know, is NuGet. So NuGet is a package manager based on PowerShell that supports downloading and installing both binary and source elements into a project. You'll find a large public repository at www.nuget.org. You can contribute components to it fairly easily, but one thing to consider is it's not monitored, so anyone can upload just about anything. You can also create your own private repositories using a folder, a network share, or a HTTPS URL. NuGet is supported in Visual Studio and officially supported with Xamarin Studio 5. Microsoft is actually moving towards this as their primary vehicle for code updates and component distribution. And also Xamarin is now shipping components like Xamarin.Forms with NuGet as well. When searching for components, it's always a good idea to look for PCL varieties, just because these tend to be a bit more compatible with Xamarin. Let's look at using NuGet from Xamarin Studio. To use it, you basically just right-click on the project and select Add Packages. Xamarin Studio 5 has a new NuGet plugin, which is fully supported and maintained by the Xamarin Studio team. It's pretty much modeled after the dialog in Visual Studio and supports searching and pre-release packages as well. It also supports auto package restore when a solution loads, which means there's no need to check in packages. Apart from that, you pretty much just find a package you want, select it, and then click on Add Package. Another option for Xamarin-specific components is the Xamarin Component Store. This is an older distribution channel that was created prior to PCLs and NuGet. However, there's still lots of great components in here. It's a smaller public repository. It also supports a pricing model, which means not all components are free. This is managed by Xamarin, so the components are validated and tested. And you'll find that most are cross-platform and support iOS, Android, and Windows Phone. In some cases, you'll find the same component in both NuGet and the Component Store. So which one should you choose? Well, generally speaking, the components here tend to be based on slightly older code than NuGet, and that's primarily because Xamarin certifies any components added to the Component Store, whereas there is no validation policy for NuGet. In addition, NuGet makes no guarantee that the component works cross-platform. You'll find that many will, but if they rely on a missing API, then the component may not function correctly in your mobile application. So I tend to prefer the Component Store. However, components in NuGet are relying more and more on PCL profiles, which will help ensure compatibility, and there's a lot more components available in NuGet as well. One thing people often struggle with is what can or should be shared. Generally speaking, anytime you write a method which doesn't depend on the platform, you can potentially share it. This includes your business or processing logic, parsing operations, web service accesses, database work, or even work with asynchronous tasks. For example, people often ask how to share the backgrounding or tombstone code between iOS, Android, and Windows Phone. The answer is, you don't really share the code which deals directly with those things because it's platform specific and quite different for each OS. However, you can share the work you do in those states. So you can place the operations you want to perform, such as downloading updates from a web service and updating a local DB into your shared code area, and then invoke that logic from the platform code, which is unique to iOS, Android, and Windows Phone. A general rule of thumb is if you find yourself repeating some code in another platform, look to see if you can write it in a way that doesn't depend on the platform, or use one of the techniques we'll show you in this class to abstract away the platform-specific requirement, so you can then move that code into something that is written only once. It's time now for a quick flash quiz to test our knowledge that we've gained so far. Question 1. All code you build with Xamarin is shareable across all platforms. Is that A, true, or B, false? The answer is false. Question 2. The main thing that makes code shareable across platforms is A, when it is related to I/O, B, when it comes from NuGet, C, when it doesn't depend on platform APIs, or D, all of the above. The answer is C. The main thing that makes code shareable across platforms is when it doesn't depend on the platform-specific APIs. Question 3. Which of the following might be possible candidates for sharing? A. Code that accesses a web service using HTTP client. B. Validation rules from my UI which use regex and return bools. C. Code that uses local notifications on the device. Or D. Code that runs an algorithm to compare flight prices in parallel. The answer is A, B, and D. Code that accesses a web service using HTTP client can certainly be shared. Validation rules from a UI which use regex and returns bool can also be shared. And code that runs an algorithm to compare flight prices in parallel could be shared as well. However, C isn't an option because local notifications are often handled differently on different platforms. Let me quickly switch over to Xamarin Studio and show you how to add NuGet and Component Store packages to your application. I'll just start off by creating a new iPhone app. So go to New Solution, select iPhone app, Single View app, click Next, and we'll just call this component example. Click on the next button, hit create. Now, all I actually want to show you is how to add NuGet packages and component store packages. So let's start off with NuGet. You can add NuGet packages in a couple of different ways. First, you can right click on the packages folder and you can select add packages. Alternatively, you can go up to the project, you can right click on that and go down to add and add NuGet packages. Both ways do exactly the same thing. And what that will do is it'll bring up the NuGet package dialog. Inside here, there's a couple of things of interest. In the top right, you can search for components. So we can come up here and we can search for JSON.NET. So this allows you to search across thousands of third-party libraries available in the NuGet library. So once you've found the component you're after, you can just select the tick box over to the left of it, and then you can click Add Package down in the bottom right corner. But before we do that, I'll just draw your attention to another couple of things. In the top left, we can see a drop-down here, which allows you to specify your NuGet source. And you'd use this if you were hosting your own NuGet packages, or if you want to connect to another NuGet source. There's also a checkbox down the bottom left-hand corner, which allows you to specify whether you also want to show pre-release packages as well. But let's go ahead and add in the JSON.NET. So we'll make sure that's selected and ticked and click on Add Package. So in our packages folder here, we can open that up and we can see that the package has been added. In here as well, you can right click on a package to update it or to remove it as well. Assembly items that are added to the project are displayed in the references and in the from packages section. So we can see our newtonsoft.json in there as well. Another thing that you'll notice is the packages.config will be updated to include the package we just installed. So our newtonsoft.json is in there. So Xamarin Studio will automatically restore any NuGet packages that are missing when your solution is opened. And that means that you don't need to add NuGet packages to your source control system. All you need to do is add the packages.config file for each project that needs to be added to your source control system. When another developer opens a solution for the first time, all the missing NuGet packages will be automatically downloaded and restored by Xamarin Studio. Finally, you can control some NuGet behavior from the Preferences dialog. So if we go up to the Xamarin Studio menu and we go to Preferences, and then we scroll down, we have this NuGet section here. And in the General section here, we can see there's a couple of options. One for package restore, so do we want to automatically restore packages when opening a solution? And also a checkbox to specify whether you want to check for package updates when opening a solution. There's also the sources section here, which is where you would configure different NuGet sources. So that's about it for adding a NuGet package. Let's have a look at the Xamarin Component Store now. So you can add components by right-clicking on the Components node and selecting Get More Components, or from this little cog drop-down, Get More Components. If we click on that, this will launch the Xamarin Component Store. And it's quite similar to NuGet, but what you'll notice against each of the packages here, you can see it shows you which platforms it's supported on, and also you'll see that some of them are free and some of them are paid. When we click on a component, it will take you to the details page for that component. And typically what you'll have is down the left-hand side, you'll have some information about the component and which platforms it supports, the version number, the price, etc. There'll typically be a video. And down below that, you'll see There's some links to tutorials, the release notes, and also down here, reviews of the package as well. Up the top, we have the Getting Started link. So if we click on that, that will just take you to links again to the samples, but also some useful documentation and links. There's also the licensing information for the component, and typically there'll also be a link out to the vendor's website as well. But to add a component in, all we need to do is click on the Add to App button. This will then install the component, and it'll show you some details about the component that you just installed, including the Getting Started guide, the samples, and the assemblies that it's using. You can see the components that are installed by clicking on or expanding the Components tab, and there we can see we have our Azure mobile services that we just added in. So it's that easy to add a component from the component store. So let's just summarize where we're up to. We've had a look at reusable components and where you can find them. We looked at using NuGet in Xamarin Studio and the Xamarin Component Library. Now let's switch gears and talk about where to place code you want to share across your mobile platforms. When writing code you intend to share across platforms, you have two basic project options to choose from. First, you have shared projects, which allow for source code sharing. Secondly, you have portable class libraries, which allow for binary sharing. Which one you select has an impact on how and what kind of code is shared. Let's start off by discussing sharing using source code directly. There are actually two different ways we can share source code. One that's been around for a long time called file linking, and a new method called Shared Projects, which was introduced by Microsoft as part of Visual Studio 2013 Update 2 to support the unification of Windows Store and Windows Phone applications. Let's start with the original file linking approach. File linking was once the mandated way to share code across platforms. It's quite easy to use. You create a source file or asset in an associated project of some kind. This can be a class library or even one of the platform projects. Then you add a link to that file into your platform projects. This means that the same physical file is associated to multiple projects and compiled into each project. This approach does work, but is sometimes tedious to add a lot of files. Also, refactoring and navigation can be troublesome with this approach because the IDE isn't aware of the relationship between the different projects. So renaming a symbol in a shared file might not catch all projects where that symbol is actually being used. These types of issues cause Microsoft to define a new way to share source files called Shared Projects. Shared Projects were added into Visual Studio 2013 Update 2 and Xamarin Studio 5. They allow you to define a specific project type where the intent is to actually share all of the files in that project with other projects. It acts just like file linking, except you only have to add one reference to your target to get all of the files added in. This then copies the files and assets included in the shared project right into your other platform projects. In addition, because the IDE knows about the relationship, all the normal refactoring and navigation tools should work just fine. The key thing to know about shared projects is that they simply define a project container. So unlike all the other project types you typically work with, shared projects do not have an output, so no exe or DLL is produced by compiling a shared project. In fact, by itself, the shared project isn't even compiled. It must be added to another project in order to have the compiler process the files. When you add a reference to a shared project, the compiler and build tools will act as if all the files in that shared project were added directly to the target. So in other words, the C# files in the shared project are compiled directly with the target using the project's build settings. The build action that you select in the shared project becomes the build action used in the target's project. So shared projects are the preferred way to manage source level sharing. The only reason not to use them if you're required to use an older version of the build tools which only support file linking. So let me quickly demonstrate how shared projects work to just solidify some of the concepts. So we'll switch over to Xamarin Studio and we'll create a new project. So we've got File, New Solution, and we'll just start off with a blank solution. So we'll select Miscellaneous and Blank Solution, and we'll call this solution Shared Demo. Click Create. And now what we'll do is we'll add a couple of platform-specific projects into here. First, we'll add an Android project, so we'll right-click on the solution and we'll say Add New Project. We'll select an Android app and we'll call this shareddemo.droid. Click Next and Create. We'll also add in an iOS application. So we'll right click on the solution, go Add New Project. We'll select iOS app, just a single view app. Select Next. We'll call this shareddemo.iOS. And we'll select Create. So now we've got two platform-specific projects, and what we'll do now is we'll just add in a shared project or a shared library. So I right-click on the solution, go Add New Project, go down to the .NET section in Other, and select Shared Project. And we'll call this shareddemo.core. Select Create. And by default, it gives me a class here. We'll just get rid of that one. And we'll just add a new class into here. And we're just going to do just a simple method just to add two numbers. So we'll just call this class Maths. And we'll add just a simple method in here just to add two numbers together and return the result. And we'll just return A plus B. Okay. We'll just quickly build that to make sure that everything's okay. So now we can add a reference to our shared project from our Android by by opening up our Android on our references, hitting Edit References. And in here we can see our shareddemo.core. And click OK. And we should find that we can now start using that method. So just in the main activity here, let's just use shareddemo.core.maths. We'll just new up an instance of that. And then I'll just get the result is math.add, and we'll just add 1 and 2 together. And then we'll just output the result. Oops. Okay, so it's that simple to reference your shared project. Let's add it now to the iOS as well. So under the shareddemo.ios, under the references, we'll go edit references. And again, we'll add a reference to our shareddemo.core and click OK. And now we should be able to get this same code here. And we'll just put it into our view controller, which is sort of the main launching point for your iOS view. And we'll put it in there. Now, one of the things you'll notice is that even though we have a reference here, the IntelliSense is a little bit broken here. So the best way I've seen to get around this is just close your files down and just close the solution as well. And we'll just close the solution. And we'll just open it back up again. We'll just do a quick build. And let's just go back into our view controller there and see now the IntelliSense has fixed itself up. Just a weird Xamarin Studio bug. Okay, so we now have both the Android and the iOS accessing our shared library. And if we do a rebuild all, we should see that everyone can build. Okay, so our build was successful across all projects. Now let's see what happens if we put something a bit platform specific into our shareddemo.code. So we'll come into our maths library here, and what we'll do is we'll just reference, say, android.app.activity, and we'll just create a new activity. Okay, just so as we're referencing something that's platform specific. Now what you'll notice is now if we do a build of the Android application, it builds fine. And we get a warning because we're not using the field, but the build works fine. But if we do a build on our iOS, it's going to fail because android.app isn't known within the iOS application. Okay, likewise, if we do a rebuild all, we'll find that the Android will work, but the iOS won't work. Okay. So let's see what happens if we remove that reference out of the iOS. So if we remove that reference out of there, obviously we have to remove our code out of our view did load. But if we're to do a build all now, everything should work just fine. So now everything is happy, and that's because it's only being referenced by a single project which has the namespace. Therefore, it's compilable against all of its targets. So that contextual support is great because it'll stop us from breaking our other targets as we modify and extend the code. However, what if we really do want to add some platform-specific code into our shared project? How do we go about that? Whether you use file linking or shared projects, you have a few options available to you when adding in platform-specific bits of code. The strategies we look at here apply equally to either approach. The first thing we can do is use conditional compilation. So keep in mind that both file linking and shared projects compile the code with the target. So the symbols defined for a given project are used. That means you can use #if blocks to isolate code with predefined symbols. Let's quickly go through these compilation symbols. First we have mobile. Xamarin projects will always define mobile, which is true for both iOS and Android application projects. So anything inside a mobile if statement would compile for Android and iOS. Next we have the Android compilation symbol. This is for code that should only be compiled into Xamarin Android applications. Then we have iOS conditional compilation symbol. Xamarin iOS defines iOS, which you can use to conditionally compile just for iOS devices. We have Windows_Phone and Silverlight. So Windows Phone 7 defines two symbols, Windows Phone and Silverlight, that can be used to target code for that platform. Windows Phone 8.1 also defines Windows Phone App for Universal Windows Phone apps and Windows App for Universal Windows apps. Over on the right hand side we can see some code which handles returning a database file in the correct format for each platform. So any platform can call this method but get back the right result. So where do you define these conditional compilation symbols? Well, in Xamarin Studio you can right click on a project, go to the Options and then Compiler tab. In Visual Studio, go to the Properties of the project and go to the Build tab. Just bear in mind you should define these symbols in both debug and release configurations. The downside of this approach is maintainability. It's really difficult to see what will get compiled and verify that code changes won't break the build for other platforms when compiling each one. Another approach is to use class mirroring. This is where you use a class in the shared project, which is actually defined differently on each of your targets. So you need to make sure you define the same public signature for any used methods, or you'll get a compile time error when you go to build for different targets. In the slide, we can see we have a Note Manager class that calls alert.show, but it doesn't actually define that alert.show. It's up to the platform-specific code to implement alert.show, depending on what it needs to do for the platform. And this works because it's all compiled in together. You'll also notice as well that the classes can be internal, again because we're compiling each of the source files with the target. So this approach is a little more maintainable, at least in terms of code clarity. However, it can still cause build issues when you aren't always building every platform together. A variant on class mirroring is to use partial classes, and this is where we split the definition of a single class across multiple source files. This is commonly used for code generation, such as in the WPF or Silverlight Designer, and also the iOS and Android Designer. In this particular case, we can have our shared source file call a method which is actually defined differently per platform by adding that method into a partial class definition contained directly in each platform. This essentially allows us to have conditional compilation, because the methods and the properties are unique to the platform. You can also use another C# feature to make your methods optional. So by defining a method as partial, it informs the compiler that you may or may not have an implementation defined in another source file. So when the code is compiled, if the method has an implementation, the generated code emits a call to the method, but if no method implementation is found, then every call made to that method is removed from the generated binary. This can be useful for cases where you potentially need to intercept calls for custom initialization or post-processing, but not necessarily on every platform. So in this way, only the platforms requiring that interception will actually define that method. It's now time for an individual exercise. So we'll have a look at working with shared projects first of all. So let's go across to the class materials and have a look at the exercise file. If we load up the start here.html and scroll down to our first exercise, working with shared projects. So our primary goal of this exercise is to load some JSON data in from a file and use it as a source to display information in an iOS and an Android application. But we're going to use a shared project in order to load the file in a cross-platform manner. Down below, there's the steps that you'll need to perform. So we're going to create a new shared project. We're going to add two shared source files, the song.cs and the songloader.cs, to our shared project. We're then going to add a reference to the shared project for each of our target projects. Then we'll add the Newtonsoft JSON.NET parser, which we'll use to actually parse the song file. Then we'll add a data file in for each of our target projects. And then finally, we'll modify the shared code to properly load the file based on each of the platforms. There are a couple of required assets that you'll need, which will be in the Part 2 resources folder. And we'll be starting off with a starter project. So there's also the steps down below which you can use to go through the project. So go ahead and pause the video now and work through the lab file. And when you're finished, unpause the video and we'll go through it together. So hopefully you got through that individual exercise okay. Let's now go over and work through the solution together. So I'm going to go over and open up Xamarin Studio. And the first thing I'm going to do is open the starter solution. So go File, Open, and then on my desktop, under Part 2 Resources, mytunes.start, and we'll open up mytunes.sln. Okay, so the project consists of an Android project, an iOS project, and a Windows Phone 8 project. But because I'm using Xamarin Studio on a Mac, I'm not going to be able to use the Windows Phone 8, so I might just remove that one and unload that project. So the first thing we want to do is add in a shared project. So to do this, we can go up to the solution node and go Add New Project, and we're going to want to specify shared project. So where you go to the .NET area and then select Shared Project, click Next, and we're going to want to give this a name of mytunes.shared and click Create. And you'll notice by default it gives you an empty class. We'll just get rid of that guy. What we'll do now is we'll add in the code, the included code into the shared project. So we'll go in here and we go Add Files, and we'll select our song and our songloader.cs and click Open, and we'll copy these to the directory. So what we have is we've got our song.cs, which is just a very basic class which just has information about a song, a bunch of different properties for the name, the artist, the album. We also have a songloader.cs, and so this has the file name in it. It has a load method, and it has an open data method, which we'll be using to add our cross-platform code in here later on. What we'll do now is we'll add a reference to this new shared project into both our iOS and our Android projects. So to do that, in my Android, I can open that up, right click on the references, hit Edit References, and select mytunes.shared. And then I'll go ahead and do the same thing under my iOS project. Right click on References, under the Projects tab here, select my shared project. Okay. Now if I do a build at this point, let's see what happens. Okay, I get an error because I don't have the newtonsoft.json NuGet package added in. So let's go ahead and do that. So we'll need to do that for both our Android and our iOS. So we'll open up our Android, go to Packages, right click, Add Packages, and then up in the search here we can type JSON. Here's our package here, so we'll select that and say Add Package. And we'll do the same thing under iOS as well. So right click on packages, select add package. Our JSON.net's already there, so we'll select that, click add packages. Okay, let's see what we get now if we do a rebuild all. Okay, and now we succeed because we have that package included. So now let's add some code into each of our projects to use the song loader to populate our UI. So we'll start off with the iOS project. So we'll open up MyTunes iOS. We'll go to the MyTunes view controller. And inside here, we'll go to the viewDidLoad method. And you already see that there's some code in here to populate the table view. We'll just get rid of that. Okay. And what we want to do in here is we want to now get our data from the songloader.load method. So we'll declare a variable data, and we'll get that from songloader.load. Okay. And what you would have noticed there is load is an async method. So we should await that and decorate our viewDidLoad with an async. Now what we're going to do is we're going to set up the table view's data source. So we're going to create a new view controller source. We'll call it view controller source. And that's going to be a new view controller source. And we're going to have songs in there. Okay, and we need to pass in a table view. Now, one thing you'll notice here is we don't have our IntelliSense in our song here. So what I typically do at this point is actually just close the solution down and then rebuild it and open it up. So I'll just do that quickly. Okay, and what we'll see here is it's actually fixed up our problem with our IntelliSense here. So what we're going to do now is assign a couple of properties in our view controller source. And the first one we want to set is our data source property. So we'll say view controller source dot data source, and we want our data source to be our data, but we need to do a toList on that. So I'll put that in and just resolve that and use system.link. Now I want to set the text proc to be the name of the song. So I'm going to do that through a lambda. So I'll go view controller source dot text proc equals, we'll just call it S. Okay, and we'll put the name in there. And next we'll set the detail text proc to be the artist name and the album. And again, I'll use a lambda to do that. Detail text proc. We'll put the artist in here, and then we'll just put a hyphen in between and the album name. Now we need to assign that view controller source to be the table view source. So we can do that just by table view dot source equals our view controller source. Let's just try building that. Okay, fantastic. So that's built. So now let's go and do a similar thing on our Android and set up our source. So we'll close this down. We'll go to our main activity. I'll just close this down first. Go to our main activity, and in our onCreate of our main activity, again, we already have a list adapter set up here, but we'll just comment that out for the moment. And again, we'll get our data. And it's an awaitable method, as we found out. So it's a songloader.load. And again, we'll need to decorate this with an async up here. Now we want to create a new list adapter. So we'll set that up. So we'll call it adapter, and we'll create a new list adapter. And we're going to have songs in here. Now, again, we want to set a few properties on here. So for our adapter data source, we want that to be our data. And again, we need to call toList on it and resolve that. Now we want to set the text proc. Okay, so we set our text proc again to be the name of the song. And our detail text proc to be the artist name and the album. Okay, and finally we want to assign that adapter to be our list adapter. So we'll say list adapter equals our adapter. And let's just do another build, make sure we're okay. Okay, and it looks like we're all good. So our next step is going to be to add the songs.json file, which we can find in our part 2 resources, into our target platform project. Okay, so in iOS, we're going to add that into our resources folder. So we can right click on resources and say add file. And from our data directory here, we can add songs.json. We'll copy that in. Okay, and we're just going to want to make sure that the build action is correct. So it should be bundle resource. We'll add the songs.json file into the Android project as well. In the Android project, it's going to go under the assets folder. So again, right click on assets, say add files, bring in the songs.json. And we're going to just want to make sure again that that build action is correct. And here it is, Android asset. Now let's go ahead and add our code to read the file. And since we've got our data stored in a platform-specific way, we'll need to use some platform-specific code to actually get that data. So we're going to have a look at the conditional compilation method of doing this. So we're going to do this in our shared project, in our song loader. Okay, and this is where we want to do this in the open data method. So we're going to use conditional compilation. So we're going to do a hash if, and if we're in iOS, what we're going to want to do is return file.openRead and then our file name. Okay. If, however, we're on Android, so we can use an elif Android, we're going to want to use something different. We're going to want to use return android.app.application context assets, because we want to read it from the assets folder, open, and then give it the file name. And just to be sure, we'll just put an else in there. We'll return null. So let's do a build now and check that we're working. Do a rebuild all. And now let's try running it on both platforms and see how we go. So let's make sure our iOS is our startup project, and we'll launch it on our simulator. And there we have it, our list of songs. Fantastic. And we'll also just test it on our Android as well. So we'll set that as a startup project and we'll start that up. Okay, and there we are. We have it running on the Android as well. And the key thing here that we've done is we've created a conditional compilation to get our songs.json from a different location for each of our different platforms. So there you have it. That's the end of our first exercise using shared projects and conditional compilation. It's time now for another flash quiz. Shared projects create an output assembly directly. True or false? And the answer is B, false. Shared projects don't include any output. They're included in the compilation of the platform project. Question 2. What types of files can you add to a shared project? A, source code only. B, source and image assets. C, source and data files. Or D, anything supported by the targets using the project. And the answer is D. You can actually add anything that's supported by the target platform. Question 3. What techniques can you use to isolate platform-specific code in a shared project? A, conditional compilation. B, partial classes. C, both A and B. Or D, none of the above. And the correct answer is C. You can use both conditional compilation and partial classes. So let's summarize where we're at. We've looked at our first technique for sharing code at the source level, and we built an application that uses a shared project. Remember, you can also use file linking on older versions of Visual Studio, but it's not as nice, but ultimately it works the same way. Next, let's examine another relatively new feature available in .NET, and that is portable class libraries. Our goals for this part will be to introduce the portable class library model, sometimes referred to as PCLs, see how they're put together, and finally look at how we can manage platform-specific code with this model. Before we talk about portable class libraries, let's talk about traditional class libraries. So anytime you create a library project, it'll be tied to a specific set of requirements. If you create a regular .NET class library project, you can change the target platform, anything from .NET 2 to .NET 4.51, and based on that choice, you know what features are available to your code. So for example, if you chose .NET 2, then you know that WPF won't be available, whereas if you choose .NET 4.5, you'd expect async await to be supported. Similarly, If you create a Windows Phone class library, you can choose which version of Windows Phone it'll be compatible with. The problem with these class libraries is we can't share them, either between platforms like Windows Phone and regular .NET apps, or with Xamarin projects. Portable class libraries attempt to address this problem and make sharing easier by letting you specify a set of platforms you'd like to target, and then have the IDE help you code within those restrictions to guarantee that the library can be shared. Portable class libraries provide a way to create portable assemblies that can target multiple platforms. That means they aren't directly tied to the runtime for a given platform, but instead can be retargeted based on the platform they end up executing on. When you create a PCL, Visual Studio will prompt you for the platforms that you'd like the library to work with, and this will decide the features that are available to the code placed within the library. Xamarin Studio selects the broadest API set, but as you'll see, you can change that in the project settings. The important thing to recognize here is that PCL projects will create a binary DLL. We're not going to share our code at the source level like we did earlier. Instead, we'll have a binary component that can be used with different flavors of .NET, including Desktop, WinRT, Silverlight, Windows Phone, and of course, Xamarin. The features available to a given PCL are defined by a profile. A PCL profile defines the combination of platforms that the PCL can be executed on and is created by Microsoft and shipped with Visual Studio. Based on the selected profile, the compiler then restricts the available APIs to be the intersection of APIs available on the supported platform for that profile. You can get a sense for how this works by the presented table. This isn't a complete list of features, just some of the more popular ones. Notice that if we choose to support Silverlight, we lose access to the system.io.compression libraries. And if we choose to support Windows Phone Silverlight, we also lose access to data annotations and possibly iQueryable. That's a trade-off for allowing the PCL to be loaded on each of the platforms. Some APIs are not available and therefore can't be used. Finally, notice the last row. It turns out that some tasks have no unity across the platforms. So file access is one of those things. Some system I/O classes are available, but nothing related to files or directories, as that API looks different on Windows Store versus the phone versus the desktop. When you create a PCL in Visual Studio, it prompts you for the initial supported platform list. The platforms you select then decide which profile the PCL is assigned to. These profiles are defined by Microsoft and shipped with Visual Studio, and Xamarin takes the defined list and ships the same profile set with Xamarin Studio. Ultimately, this profile will decide which APIs are available to your code in the PCL. You can change the supported target platforms through the Project Properties dialog in both Visual Studio and Xamarin Studio. And the more platforms you choose to support, the more limited your API selection will be. You should always strive to pick only the frameworks you need, because the more targets you include, the more restrictive the API set will be. Remembering that you're only able to use the APIs that are available on all the platforms you're targeting. One area where the profiles will start to show in Visual Studio is if you don't select enough targets. So earlier we saw the system.io.file isn't supported for any PCL configurations. However, .NET 4.5 and Xamarin iOS and Android both clearly support the class. So in theory, if you just selected those three platforms, then you should get access to the entire file directory API subset. That doesn't work, however, because there is no profile which only includes .NET 4.5 and Xamarin iOS and Android. You must select at least one more target, and none of the other targets support those APIs. In Visual Studio, if you haven't been specific enough, it'll simply warn you with some text at the bottom of the dialog and automatically shift you to the closest profile that supports your selection. In Xamarin Studio, however, you're not allowed to proceed until you actually make a selection that matches a specific profile. So let's jump over to Xamarin Studio and have a look at how we can create a portable class library. What I'm going to do is create a new solution. And I'll just create a blank solution. And I'll call this PCL Demo. Now I'm going to add an Android application in here. So I'll go add new project, just select an Android app, and I'll call this PCLdemo.droid. And we'll also add in an iOS application as well. So just select iOS single view app, and I'll call this PCLdemo.iOS. Click create. Now what I'm going to do is add in a PCL project to our solution. So again, I'll go up, select, in my solution, add new project, and you'll find the PCL projects down here under .NET, and you've got portable library. So I'll call this PCLdemo.core and hit create. Now what you might have expected Xamarin Studio to do is ask what platforms we want to support, but Xamarin Studio has a best guess at it. And we can see what it selects by opening up the project options and clicking on the General tab. So let's just do that. Go to our project options, and if we select the General tab, you can see it's already selected PCL Profile 78. And these are the target frameworks that it supports. I could, if I wanted to, change the PCL profile from up in this list here, or I could actually come through here and select which platforms I want to support. And you'll notice here that we have to meet the minimum requirements of a PCL profile. Okay, but I'll just change that back to 78, which is what we had, and click OK. Now what we want to do is add a reference to our PCL demo core to both our Android and our iOS applications. So I can go and right click on references, go edit references, and here in my project you'll see my PCLdemo.core. Click OK. And you'll see that adds in the PCLdemo.core reference. I'll do the same thing under iOS. So right click on references, edit references, PCLdemo.core, and click OK. And again, you'll see that we have our PCLdemo.core. Now, if I just do a build at this point, let's just have a look at what we get in our output. If I go and open up the containing folder, okay, what you'll see is under my bin directory, under debug, I have this PCLdemo.core.dll. And that's because we're sharing a binary and not just code files. Okay, so it actually builds a DLL for us. Okay, so let's go and add something into our PCL demo class. So first I'll get rid of the empty class. I'll just remove that. And we'll add another one in, and we'll just add a simple class to just add two numbers together. So we'll go add new file. I'll add a class called mathlib, and I'll just add a simple method into here just to add two numbers together. So it'll be called add. It'll take in an int and another int, and basically it's just going to return the result of those added together. Okay. Now let's have a look at calling that from our Android application first. So we'll go into our main activity, and because we've got a reference to our PCLdemo.core, we should be able to now go PCLdemo.core.mathlib, new up an instance of that, and then call the add method. Okay, and it works pretty much how you'd expect. And because I have a reference in iOS to my PCLdemo.core, I can actually take this same code across here and put it in my iOS application. So I'll do that in my view controller, in my view did load. Okay, and you can see I can do that from in here as well. Like I said, pretty much exactly as you'd expect. But now let's go over to our PCL, and we'll try adding a reference to something that's not in the PCL profile, and we'll see what happens. So we'll go across to mathlib. We'll put in a using system.io. That's all good. And now what we'll try and do is we'll try and access a file from in here. So I'll go file equals file.open. Okay, but we're not able to because file doesn't exist in this PCL profile. So basically I can't use this file object. And because it's a PCL, I don't have conditional compilation either. And the reason that conditional compilation won't work is because the PCL core is getting compiled by itself. It's not part of an Android or an iOS project. It's just a DLL, and the DLL has to support every target that you select. So this limited API means that we either need to restrict our code to a fairly small subset of the framework, or we need to provide some way to execute platform-specific code through an abstraction. So let's talk about that. Because PCLs share code at the binary level, the platform-specific APIs cannot be added directly into the project. In addition, a lot of the other essential APIs are missing as well. So for example, you've already seen that no file access APIs are present. We do have the system.io.streamReader, but only the constructors that take a stream are present. At first glance, you might think that this makes PCLs pretty pointless as a cross-platform technique. However, there are several strategies we can employ that will help us compensate for this restriction. To get around this restriction, we can take a couple of approaches. The first thing we can do is limit our API. For example, we could change our method to take a stream as input and have the caller use the appropriate API to open the file and turn it into a stream. System.io.file on .NET and Xamarin and storage file on WinRT, for example. This puts more of a burden on the caller, but if the API is simple enough, it's certainly a valid option. Alternatively, we could put a little architectural thought behind our library and move to an abstraction that allows us to provide an implementation for our platform-specific code. This is the approach that we'll focus on. Here's one example. If what we need is a small number of self-contained actions, PCLs can use events on types to request extensibility from the consumer. In the example on the slide, we have an event on the PCL, and the Note Manager iOS subscribes to the Note Manager Show Alert event. And you could do similar code on the Android and the Windows Phone implementation using the appropriate API for the platform to display a dismissible alert. For more complex scenarios that might have associated behavior, we can provide a contract in the PCL in the form of an interface or an abstract class, and then provide an implementation of that contract in each of our platform-specific projects. And in this way, we push the platform logic into the platform assemblies. So here you can see we need some ability to load notes. Each platform stores them in a different location, or possibly even using a different technology altogether. One may store it in a database, one in XML, one in the cloud, etc. So we define an interface, the iNote data loader, which will describe our requirements. The Note Manager then relies on the interface, and the platform-specific code provides a concrete class that implements the interface. And then finally, we have to tell the PCL about the implementation. There are several different ways to accomplish this. We could use a service locator pattern, which is a singleton where we dynamically register dependencies. We could use the factory pattern to return instances, or dependency injection. And we'll look at some of the others in the advanced cross-platform class when we talk about architectural patterns. But let's focus on the most common technique, which is dependency injection. This is where we pass the implementation into the PCL through a constructor, a method, or a property. And you can see examples of each of these on the slide. So which one should you choose? A good rule of thumb here is if the code can't work without the dependency, then you should use constructor injection. If it's optional, then use property injection, unless it's only used in a single method, in which case you'd probably want to pick method injection. It's time now for another individual exercise, and this time we're going to be looking at working with portable class libraries. So let's go over and have a look at the exercise file. So we'll open up our start here. And we'll scroll down to exercise 2. And in this lab, we're going to be starting off almost where we left off in our last exercise. But this time we're going to do it with a portable class library instead. The steps that we're going to go through are we're going to create a new portable class library project. And again, we're going to add those two shared source files, the song.cs and the song loader. Then we're going to add a reference to the PCL for each of our target projects, include the NewtonSoft.json.net NuGet package. Then we're going to create an abstraction to open a stream and implement it on each of our platform projects. We're then going to use the abstraction in the portable code, and we'll use dependency injection to do this. There's some required assets we'll need for this lab, and you'll find those in the Part 3 resources. And down below, there are the steps that you can walk through. So go ahead and pause the video now and give this exercise a go. And when you're finished, unpause the video and we'll go through it together. So hopefully you made it through that lab exercise. Let's work through it together now. So we'll start off by jumping across to Xamarin Studio. So let's start by opening up our starter solution. So we'll go File Open, and I've got it on my desktop, but we'll go for Part 3, mytunes.start, and we'll open up the mytunes.sln. Now what we'll do is we'll add in a portable class library. So we'll click on the solution and we'll say Add New Project. And this time we want a portable class library. So we come down here to the .NET section and we select Portable Library. Select Next, and we'll call this mytunes.shared. And click Create. Again, we'll go through and just delete that empty class. Now let's add the song and the songloader.cs into our shared project. So we'll right click on that, we'll say Add Files, can select song and songloader.cs. If we have a look at the songloader.cs, we'll see that we need to add a reference in to get this NewtonSoft.json. So let's do that on our portable class library. So right click on packages, say add package. We want json.net, select that and click add package. Now we'll add a reference to the PCL for each of our target projects. So from our Android, go into references, say edit references, and we can see mytunes.shared. We'll share that, we'll include that PCL. And we'll do the same thing for our iOS. Let's look now at creating a file abstraction. And since we've got the data stored in a platform-specific way, we'll need a platform-specific piece of code to get our data. So what we're going to do is we're going to create an abstraction. So we'll create a new interface in our PCL. So if we right click on here and say add new file, and we'll create an interface, and we'll call this interface iStreamLoader. This interface is just going to have a single method which will take a file name and return a stream. So let's add that in. And we'll take a file name. We'll have to resolve our reference there. Now let's add an implementation of this interface into iOS. So we'll come into iOS here and we'll add a new class in. And we'll call this class StreamLoader. And we'll implement our interface. We want to resolve this as MyTunes shared, and what we want to do is we want to implement this interface. So to implement this in iOS, all we need to do is, just like we did in our shared, we just go return file.openRead, and then the file name that we passed in. To resolve a namespace there. And now we'll go ahead and do the same thing on our Android. But in order to do this, Android is a little bit different in that Android assets are loaded through an Android context. So we need to pass in a context to the constructor of our implementation. So in our Android here, we'll add a new file, again an empty class. We'll call this StreamLoader again. And we'll implement iStreamLoader. So let's resolve that and then implement this interface. But in this constructor here, we're going to have to pass a context in. Okay, and that's an Android content. We'll just declare a variable to hold this. And we'll store that away in our constructor. And then in our implementation of getStreamForFile, we'll return context.assets.open and then the file name. Next, we need to inject the abstraction. So we need to provide the abstraction to the PCL. So let's do this in our songloader.cs file. What we'll do is we'll simply add a static property named loader of type iStreamLoader. So a public static iStreamLoader and resolve that. What we'll also do is we'll edit our open data method to test the property for null, and then we'll use it to open the file name. So we'll say if loader is null, then we'll throw an exception. Okay, and then we'll return loader.getStream for file name and the file name. Next, we'll set the property in each of our platforms for our implementation. So we'll do this just before we call the async songloader.load method. So we'll do that in the iOS first. So we come to MyTunes View Controller, and right in here, we'll pass that in. So we'll say songloader.loader equals new, and give it our stream loader. On the Android side, we'll do something similar in our main activity. Okay, but remember, for Android, we need to pass in the context as well. So we'll say songloader.loader equals new stream loader. But remember, we have to pass the context in, so we can pass in this. Okay, so let's give that a build now and see how we go. All right, that seems to have worked. So let's now test the application on each of our platforms. So we'll start off with the Android. We'll set that as the startup project. We'll set our emulator and we'll start that up. Okay, and there we go. That's seems to be working on our Android. And now let's try it on our iOS. And there we go, that seems to be working as well. And there we go, we've done an implementation using a portable class library and used it in iOS and Android using dependency injection. And so that brings us to the end of exercise 2. Now that we've seen both techniques, the obvious question is, which one should I use? The slide here outlines the pros and cons of both the shared projects and portable class library. But there is no clear-cut answer here. It really depends on how you want to architect your application, the size of the team building it, and what your build process is going to look like. For smaller apps with smaller dev teams where you have all projects loaded into a single solution and you intend to update them all simultaneously, shared projects make a lot of sense. They're simple, easy to manage, and support extensibility in ways that PCLs can't. However, we have to have access to the source code to use them, remembering that there is no distribution model beyond that. So when your teams are larger and you don't want to include all the projects, or you have true reusable components, it makes a lot more sense to turn to PCLs. They force you to architect your application and make you think about what is truly shared. Ultimately though, the choice is up to you. You can always change back and forth if you find one isn't working for you, and you can of course mix and match them in your development as well. So you might have some things built in a PCL, which you intend to use with other applications, and the local logic in a shared project because it's only used for this application. It's now time for a final flash quiz. Question 1. Portable class libraries share source code across projects. A, true, or B, false? And the answer is B, false. Question 2. When you define your platform targets, you're selecting A, configuration, B, platform group, C, profile, or D, grouping. And the correct answer is C, profile. Question 3. Which of the following is not a platform supported by PCLs? A, .NET 2, B, Windows Phone 8 Silverlight, C, Windows Phone 8.1, or D, Windows Store Apps? And the correct answer is A, .NET 2. Question 4. What techniques can I use to add platform-specific code to a PCL? A, dependency injection, B, service locator, C, publisher subscribe, or D, any of the above? And the answer is D, any of the above. So let's just summarize. Now we've seen two techniques for sharing code across your supported platforms. The first was at the source level using shared projects, and the second was sharing at the binary level with portable class libraries. And that brings us to the end of XAM110 Introduction to Cross-Platform Development. Thanks for watching the video, and hopefully you've learned a few things along the way. As always, feel free to reach out to me on email. Have a great day, and I hope to see you on future classes.